Section 9.6 has us working with solving equations that involve square roots. So we're diving right in, at the start of this, into the process that we are going to be using. As we've done in previous videos, I recommend taking a pause and writing down the highlighted bullet points as necessary for yourself. We're going to go through these and then dive right into some examples. So at the beginning of this, the first thing that we want to do is we want to isolate a radical term to one side of the equation. Now, the wording with this is very, very important because we are going to see problems, as you might be seeing down below here with example 3 and example 4. I have multiple radicals in this problem, in those problems. So our goal at the beginning is to isolate a radical term to one side of the equation. We just want one of the radicals all by themselves. We'll deal with the second one later on if it shows up. So once I have a radical all by itself on one side of the equation, then I'm going to raise both sides of the equation to a power equal to the index of the isolated radical, and then simplify each side individually. Now for the purposes of this video, we are working with square roots, so we are going to be raising everything to the second power. Again, the main reason behind this is going to cancel out and simplify by getting rid of some of the radicals that we have on one side. We have right here. So one radical should be gone right after we've done this step. We now have two possibilities that show up here, and it's on a problem by problem basis which one will or will not show up. There's really no way to guarantee and get rid of everything all in one go. So our first possibility is the following. Radicals remain somewhere in the equation. If that is the case, then we need to go back up to steps 1 and 2, we have right here, and we're going to repeat those as many times as necessary until all radicals are eliminated from the equation. This means we might need to isolate a radical and then raise both sides to a power 2, 3, 4, 5 times in a single problem. Now, most problems aren't going to have you do it that many times, but we'll at least see an example or two where we have to do it twice, which is a fairly common occurrence. Now eventually we're going to get to the point where all radicals are eliminated, which is fantastic. That's what we ultimately want to get to. At that point in time, we can then solve the resulting equation using any previously learned methods. Most instructors and most equations or problems are going to say, solve the following equation or solve these equations, something like that. They don't really specify using method A or method B or method from this section or anything like that. So use anything you've learned to go through and solve what's left over. Now the final step with this, and this is something that we have some flexibility in how we want to go about checking this, but it is something that needs to happen. We need to check our final answers. Remember that square roots cannot produce a real answer if the radicand is negative. It would mean we have no solution as a final answer. So we can see in some of these problems where maybe we'll get an m value or an x value or something like that, where this looks like a reasonable answer after I've gone through steps 1 through 3. However, when I plug that number back into my original problem and check for an answer, it turns out that maybe this radicand ends up being -7. I can't have the radicand be negative and take the square root of it, so therefore I would have no solution. But that is not inherently obvious when I just go through and find x equals something or m equals something else. So we want to make sure we go back and check those as we're going through each of these problems. So let's take a look at our 4 examples listed down here and see what this looks like in practice. Here we have our first example. We're taking the square root of 5m minus 4. We're subtracting 2 from that, and the result is going to be 7. So to solve this thing, let's go back and use our process. Step 1 says to isolate a radical term to one side of the equation. So we have the radical term all right here. That's the radical and everything inside the radicand all as one big thing. You could think of it as a big box, as it were. Now I want to get rid of everything on that side that isn't that radical. So it means I need to get rid of this minus 2 over there. So I'm going to do that by adding 2 to the left side, and that means I have to also add 2 to the right side. Once I do that, my new equation looks like this. I now have the square root of 5m minus 4 equals 9. At this point in time, we go to the second step, which says to raise both sides of the equation to a power equal to the index of the isolated radical, and then simplify each side. So the index of this radical is 2, which means I'm going to raise this entire side to the second power, and I'm going to raise the entire other side to the second power as well. On the left side, the square root and a square are going to cancel each other out. The exponent up here and the radical itself, those are going to cancel out, and all that's left over is 5m minus 4. On the other side, I have 9 squared. That's going to give me 81. So each side is fully simplified. Now looking at step 3, we had 2 possibilities. Do I have radicals left over or not? And in this instance, I have no radicals left over. So if all radicals are eliminated, then we solve each of the resulting sides of this thing, and we find our final answer. So we can use any method that we have to solve this for m. So I'm going to be adding 4 to both sides. It's going to give me 5m equals 85. Then from here, I need to get m all by itself. So the only way I can do that is to divide both sides by 5. So left side divided by 5, right side divided by 5. On the left side, I'm getting m. On the other side, 85 divided by 5 is going to give me 17. If you need to use a calculator for some of these larger computations, you're welcome to do that. Some of the numbers can get a little gross, so do that if necessary. So we now have a potential answer of m equals 17. Awesome. Now we need to go through and check our answer. Make sure that we have the correct thing here. So my recommendation is let's write out for ourselves, I'm checking that m equals 17 is an answer. So when I write this out, I think it's good practice to write the original problem at least once for yourself, and then the next line below that actually plug in the number that you found. At this point in time, we want to simplify this whole left side on its own, and I want to simplify the whole right side on its own. So on the left side, 5 times 17, I'm going to use a calculator off screen here, which you're welcome to do as well. That's going to give me 85. (85 minus 4), that's going to give me 81. Square root of 81 is 9. Oops, should equal 7 on the right side. And I'm getting 7 is equal to 7, which is good. And that tells me that m equals 17 is my final answer for this problem. It should be noted that when you are doing the check process over here, we should absolutely never be adding or subtracting or multiplying or dividing something to both sides of this equation. I'm just looking at the left side all by itself and simplifying using PEMDAS, and then I'm just looking at the right side all by itself and simplifying using PEMDAS. Looking at our second example, we're going to use the exact same process that we did to go through and find our answer here. So for this problem, we are again trying to isolate a radical to one side of this equation. So I need to get rid of this plus 2 on that left side. So to get rid of adding 2, I'm going to have to subtract 2. On the left side, I'm going to be left with the square root of x minus 2. And on the opposite side, I'm left with x minus 2. It is perfectly fine if we have a quadratic statement or a polynomial showing up on the opposite side. It's a pretty regular occurrence. And while our numbers and processes can get a little bit gross, as we're going to see with this problem, that's perfectly fine. We can still get to our final answer from here. But our main goal is to isolate the radical to one side of the equation, so we've done that. It's our first step. Step 2 is to raise both sides of the equation to the power equal to the index and simplify from there. The index of that radical is 2, so that means I'm going to square this entire left side and square the entire right side. Again, it should be noted that it is everything that was over here that's being raised to the second power. On the left side, we're going to be left with x minus 2. And on the right side, we're left with, well, I'm going to have x minus 2 times x minus 2. It is the entire right side multiplying by itself twice. So I have x minus 2 times x minus 2. Let's go ahead and further simplify the right side using the distributive property. And I should be getting x squared minus 4x plus 4. So that's using the distributive property and combining like terms on the right-hand side there. We now look at step 3. We have the two possibilities. Are there radicals left over or are there not? I'm not seeing any in this problem, so this means that if all radicals are eliminated, we solve the resulting equation using any of our previously learned methods. Up till now, our only method that we have for solving an equation like this is to get everything to one side of the equal sign and then solve this using factoring. So the way I'm going to do that, I'm going to subtract x from both sides. I get minus 2 equals x squared minus 5x plus 4. And then I'm going to add 2 to both sides. I want everything on the right side of this equation, the left side equaling 0. So I now have this in standard form. Everything on one side equaling 0. And I check to see, can I factor the right side of this equation using my previously learned methods? And we can. This is using the, I believe it's 7.2 material. So when we factor this thing out, this can factor into x minus 2 times x minus 3. So what are our two potential answers that we have here? It could be that x is 2, or it could be that x is 3. We now need to check both of these because we want to make sure we don't have any radicans that are negative showing up in this problem. So we're coming back up to the top here. Or at the very least, this is how I like to go through and check it. You're welcome to use a slightly different organizational method, whatever works best for you. But we do need to go through and check these things. So I'm checking x equals 2 first. So I'm going to plug this into my original equation. So anywhere an x shows up, I'm plugging in a 2 inside of a set of parentheses. And I'm simplifying each side individually. On the left side, I have the square root of 0 plus 2 equals 2. And I'm getting 2 equals 2 here. So that's good. 2 is an answer, or x equals 2 is an answer. Fantastic. Let's go through and check our other potential answer. We're checking x equals 3, I believe. Check here. Yeah, got the right thing. Always make sure you're plugging in the right number into these things when you're checking them. I've had the occasional time where I'll plug in a positive of something, and I should be plugging in a negative or something like that, and it goes horribly wrong. Don't make my past mistakes. So if I'm looking at this, I'm getting the square root of 1 plus 2 equals 3. The square root of 1 is 1, so I have 1 plus 2 equals 3. I'm getting 3 equals 3. Excellent, that's what I wanted. Both sides are the same. And that tells me that both x equaling 2 or x equaling 3 are our final answers. And again, as we're going through these and doing any of these checks on the right-hand side here, there's absolutely nothing wrong if you want to do these checks inside of a calculator. You're more than welcome to do that. Just remember, you're only checking the left side all by itself, and then you're checking the right side all by itself. Looking at example 3, we're going to go through and solve this thing the same way we have the past two. Our goal is to isolate a radical to one side of this equation. Now we're noticing in this problem that we have a radical on the left side and a radical on the right side. Thankfully, there's nothing else being added or subtracted to the end of these, and there's nothing that's being multiplied or divided in front of these as well. So, as it turns out from the very beginning of this problem, each radical has been isolated to each side of this problem, which means our first step is basically done for us and we didn't need to do anything. Yay! A little less work is always nice, right? So our second step then says, raise both sides to a power equal to the index of the isolated radical. Well, both of these are square roots, so both of these sides are being raised to the second power, or they're being squared. Now in this instance, on the left side, the square root raised to the second power is going to cancel, and I'm getting 7y plus 1. And on the other side, I also have a radical being raised to the second power, a square root being squared. So the radical is going to cancel, and I'm left with 2y minus 5. Then taking a look at step 3, do I have any radicals left over? No, I don't. So I'm just solving this thing with information that I've been given. Just 7y plus 1 equals 2y plus 5. Or minus 5, I should say. Awesome. So I'm going to get rid of the variable terms on one side of this equation. So I'm going to eliminate them on the right side because it's a lower value. I'm getting 5y plus 1 as a result on the left side. And that equals negative 5 on the right side. Again, still solving for y. I'm trying to get that all by itself. So I subtract 1 from both sides, and I'm getting 5y is equal to negative 6. Oops, make that a better 6 here. There we go. From here, I'm still trying to get y by itself. It has that 5 attached through multiplication, so I'm going to divide both sides by 5. And getting my potential final answer as y equals negative 6 over 5. There's nothing wrong with having a fraction answer. We see it show up fairly regularly. It can also be a negative. There's nothing wrong with that. But we're going to go through and check both sides of this equation to see what we get and see if we can get an actual answer for this. So again, I'm noting to myself, I'm going to check this thing. What am I specifically checking? I'm checking that y is negative 6 over 5, and that's going to be an actual final answer. So I'm plugging that in. Again, always start with the original equation as it's been given to you. And then we're going to simplify each side all by itself. So on the left side, when I go do that, if I plug that entire radicand, this 7 times the square root, or 7 times negative root 6 over 5 into my calculator, and I'm doing this off screen, which you're welcome to do as well. When I plug that in, I'm getting, oops, hold on, it's giving me a little bit of an error over here. There it goes. So I'm getting the square root of the fraction negative 37 over 5 on the left-hand side. On the right-hand side, I'm getting the square root of, and I'm going to again plug that entire radicand into my calculator and let that do a bunch of the heavy lifting for me. And I'm getting a negative 37 over 5 over here as well. Now this is where it gets a little deceptive. We look at these things and we say, well, the left side is the exact same as the right side. They are equivalent to one another. And while that is true, can we take the square root of a negative radicand and get a real answer? No, we can't. So based on that, we cannot actually have a real solution to this. So from there, we get imaginary answers. These are referred to as complex numbers, which we get to at a different section. But because I have no real answers to this, only imaginary one, I'm going to write out my final answer here, no solution. You could also write it out instead, if you wanted to, as no real solution as well. Make sure you're clarifying with your instructor which one of these answers your instructor would want, but either of them should work just fine. If you're using an online program, make sure you're double checking if it says something to the effect of entering in NS for no solution, or maybe it has a special symbol that you're using or that software uses to put in that final answer here. That either one of these should work. In our fourth and final example that we have here, we're probably going to see the most advanced and maybe the trickiest version of what most of these problems are going to look like. So let's dive into it and use the same process that we've been using up till now, because that's going to go through and get us to our final answer. I want to isolate a radical term to one side of the equation. It's our first step. I'm looking at the left side and noticing I have a radical plus something on the left side. And on the right side, I'm looking at it and noticing I have just a radical over there, which is fine because our goal in our first step is to isolate a radical to one side of the equation. So I've done that on the right side. Awesome. Now I can advance on to step 2. And that tells me to raise both sides of the equation to a power equal to the index. So that means the entire right side is going to be raised to the second power, and the entire left side is going to be raised to the second power. Now, as we saw in a previous example, we need to expand and multiply everything out when I have two terms showing up on one side, something plus something else or something minus something else. On the right-hand side, the radical is just going to cancel with the exponent. I'm going to get 4a plus 1. On the left side, I would highly recommend writing this out in expanded form, which is to say we have square root of a minus 2 plus 3 times the square root of a minus 2 plus 3. And now we are going to need to apply the distributive property and multiply everything through to get to our answer. I need to simplify the left side down as best I possibly can. So I'm going to take the square root of a minus 2 and multiply it through to everything inside the second set of parentheses. When I do that, I'm getting a minus 2 plus 3 times the square root of a minus 2. Square root a minus 2 times the square root of a minus 2 is going to cancel out to give me a minus 2 left over here. I'm then taking this 3 and multiplying it through to everything in that second set of parentheses, and that's going to give me 3 times the square root of a minus 2 plus 9. And the right side hasn't changed, it's just going to stay exactly as it is. Now looking at this left side, I'm going to continue to try and simplify and condense things down as best as I possibly can. I have a whole lot going on here, so simplifying is really helpful to get rid of and make things a bit easier to look at, I should say. So I'm combining things where I can. I'm going to combine these radicals together. That's going to give me 6 times the square root of a minus 2. I can also combine these constants together. That's going to give me, 7? Plus 7. And then I have a over here as well. I can't add that with anything else because these a's are radicands. They're inside of a radical, so I can't do anything with those. But now the left side is as simplified as it possibly can be. I'm looking at the third step, and we have two possibilities. Radicals remain somewhere in your equation, which we do have right here. We then repeat steps 1 and 2 as many times as necessary until all radicals are eliminated from the equation. So that means, going back to step 1, I need to isolate a radical term to one side of the equation. So I want to get this square root of a minus 2 all by itself. I want to get rid of all of this, and I want to get rid of this 6. My recommendation is to do the addition and subtraction first, and then we'll deal with multiplying or dividing at the very end. So I'm going to subtract a from both sides. I'm also going to be subtracting 7 from both sides. I'm going to do this in one step just to save a little bit of time. On the left side of the equation, I'm getting 6 times the square root of a minus 2. On the right side, I'm going to be getting 3a minus 6. Now from here, my radical is closer to being all by itself, but it still has this 6 attached out front. As a coefficient, that 6 is being multiplied to the square root, so I have to undo multiplication with division, which means I'm dividing the entire left side by 6. Now it's your choice on the opposite side if you want to divide the entire thing by 6, which you can do. I'm going to take a slightly different route, and I'm going to instead divide each thing by 6 here. I tend to like this route because it makes it easier for me to see how I can cancel and simplify fractions down. On the left side of this equation, I'm getting the square root of a minus 2. On the right side, I'm getting 1/2 times a minus 1. So I now have a radical term isolated to one side of the equal sign. Perfect. Our second step then says to raise both sides of the equation to a power equal to the index. So I'm going to be squaring the entire left side. I'm squaring the entire right side. And again, it's everything over here raised to the second power. So if you need to, expand that out for yourself. So it's going to be 1/2 a minus 1 times 1/2 a minus 1 we have here. I'm going to simplify the right side down using the distributive property. I'm getting, looks like 1/4 a squared. As I'm multiplying through here, I'm getting 1/4 a squared. And then, let's see, it's going to be minus 1/2 a, and then minus another 1/2 a. So I'm getting that there. And then what's it going to be? Plus 1. So the right side has been multiplied out and simplified down. And now that I have no radicals left over, I can go through and solve this thing as I've done previously. So my only option is to get everything onto one side of this equation and solve it using factoring. So I need to subtract a from both sides. I'm going to be adding 2 to both sides. My goal is to get rid of everything on the left side of this equation here. So that left side becomes 0. The right side is going to become 1/4 a squared minus 2a plus 3. And now I have everything in standard form. From here, I'm not liking that I have this radical, or not this radical, I should say, this fraction showing up. I want to eliminate that fraction. So what I'm going to do is I'm going to multiply every single term in this equation by the lowest common denominator of all fractions in the entire equation. So because I only have one fraction, I'm going to multiply everything by 4. We'll make a note of that off to the side here. I'm just going to note the lowest common denominator is 4. So that means that everything, every single term, is going to multiply by 4. Whoops. Even if it doesn't have a fraction explicitly written in there, I'm still going to have it multiplying by 4. Every single thing gets multiplied by 4. I'm getting a new equation of 0 equals a squared minus 8a plus 12. And from here, this is a lot more straightforward on how I can go through and factor and cancel this thing. I'm going to move us up, because I'm way beyond my original starting space here. And we'll go right here. So I have 0 equals, and when I factor that thing, I'm just going to rewrite it here first. There we go. A little bit easier. So when I factor this, it's one of our special forms. Not really a special form, but this was the 7.2 material. We have a little bit of a shortcut with this. I'm saying what two numbers multiply to give me 12 and add together to give me -8. That's going to be -2 and -6. So my potential A values are 2 and +6 here. And now I need to go through, I need to check these things. Again, when you're going through and checking these, you can only do one at a time. You are welcome to use a calculator to help go through and speed up this process if necessary. So I'm taking the square root of 2 minus 2 plus 3 equals the square root of 4 times 2 plus 1. So simplifying the left side down, I'm getting the square root of 0 plus 3. Left side is just going to be 3. Simplifying the right side down, I get the square root of 4 times 2 is going to be 8. 8 plus 1 is 9. The square root of 9, the positive square root of 9 is 3. So a equals 2 works. Awesome. Let's check our other number. We're checking if a is 6. Do a little bit of this just to divide up our work a little bit. And again, when you are doing this, I think it is very helpful to at least write out what you are plugging in once. You're welcome to use a calculator to speed up the rest of the process from there. But write it out for yourself at least once so you can see what you're doing with this thing. So on the left side, I'm getting the square root of 4 plus 3. Square root of 4 is 2. So 2 plus 3 is going to give me 5. We'll check the other side. We're getting the square root of 24 plus 1. 24 plus 1 is 25. So the positive square root of 25, that is 5. Excellent. So that tells me that a equaling 6 is an answer. Therefore, both of my two potential answers absolutely work, this thing. So I'll try and zoom this out here, see if I can get most of the process in one shot here. It's about as good as it's going to get. So make sure as you are going through these things, you are going back and referencing the process. It's a pretty common occurrence that we're going to have two radicals showing up at the very beginning, and partway through we have to go through and multiply everything out again like we did here. It's not that you're doing anything wrong. It's not that there's some other trick to get rid of all of them at once. This is just the process we have to go through with problems like this. And yes, it does take some time, but we have to go through it all the same. So as a quick summary of everything we did in 9.6, we had our main process that we followed here. If you haven't written these down for yourself, I highly recommend you do that. And make sure you are checking and following these steps as you are going through the problems. As you saw with our 4 examples that we went through down here, it doesn't mean it's only going to be 3 or 4 lines of work. As we saw with example 4, it's a lot more than that sometimes. But use these processes and these steps as a route to get from the very beginning to your final answer. There's nothing wrong with referencing them as necessary. So we'll scroll down here a little bit and give you some practice problems that you can go through on your own. Again, I'd recommend pausing the video here to give these a shot all by yourself or with people around you if you're working on this in a group. And we'll scroll down and get you the answers here. So it should be noted, looking at the group 2 problem, and as we saw with one of our other examples, it is perfectly possible for us to be given problems where I'm going to look through it and I'm going to have no answer left over. Or maybe it's a problem where I get 2 or 3 potential answers, but only one of them actually works once I check my potential answers at the very end of the problem. But otherwise, this is everything for our 9.6 material, solving equations with square roots.